Okay, good evening, everybody. Welcome to this week. Good evening, everybody. Welcome to week 4 of the interactive session on programming in modern C++. So let's begin today's session. So in this week, we learned about, like Sir taught us about static data members and static member functions, and we learned about the friend function and friend class. So this friend is a keyword. Okay, so what happens when we append this keyword to a function or a class? And then we learned about operator overloading for user defined types. So there were two videos, so this is 1 and 2. And then we learned about namespaces, so which is also an important part of C++. So first we will go over uh, the static data members and member functions. So static is a keyword which we can append to a data member or a member function, and when we do this, then the static data member is associated with the class and not with the object. Okay, so when we append this static keyword to a data member, then it is associated with the class as a whole and not with any specific object. And a static data member is shared by all the objects in a class, and it needs to be defined outside the class scope. So this one I will show later. Okay, so basically we know that we have a 1 minute. Okay, so we know that we have a class, and this class can generate multiple, we can create multiple objects from this class. Okay, we can create multiple objects from this class, and we also know that each of the objects have their own instances of data members. Okay, which is known as the state of the object, and and these data members are independent of each other. But what we can do is, we can, when we you create a static data member, then that data member is shared between all the objects of this class. Okay, so all of the objects will have one common data member. Okay, one common instance of the member, and each of the objects can modify that same thing. Okay, and so therefore the static member is associated with the class and not any specific object. And also another thing is that it has to be defined outside the class scope. So which means that, let us say we write the class definition, but we cannot, let us say that we write the class definition, but we cannot, initialize the data member inside the class. We have to do it outside the class scope. uh, Next is static member function. So a static member function is similar to static data member, in that you can think that the function is associated with the class itself and not any specific object. Okay, so a static member function can only access uh, static data members. Okay, it cannot access non-static members. Why? Because since the static member function is not associated with any object, you can call it without creating any object also. Okay, so in that case, let us say that we have a class, and we have not defined and we have not created any objects of this class, but we can still call a static member function. Okay, and what will happen is that it will be able to access only the static data members, because the non-static members have not been initialized. Okay, and it also cannot invoke any non-static member functions. So you may ask that what is the use of such a member function. So it is just for convenience sake. Okay, sometimes what happens is that there might be a function which logically belongs to the class, but associated with any it is not associated with any object. Okay, uh, okay, like let us say that like I have an example. Let us say that we are defining a class called circle. Okay, now a circle can have one data member which is the radius of the circle. Okay, and then we can have another data member, let us say pi. Okay, now pi does not depend on any instance of the circle class. It can be shared by all the members, right? Because it is independent of the radius of the circle, so we can make pi a static data member. Similarly, let us say that we have a function called pi. Okay, which returns the value of pi. So this will logically belong with the circle class, but it does not depend on the radius of the circle, so we can make it a static member function. Okay, now let us proceed. So now we'll look at the friend functions and classes. So basically a friend function of a class, we have like in there are two contexts in which we can use the friend keyword. Either we can make a class a friend of some other class, or we can make a function a friend of some class. So first I will go over the friend function. So friend function of a class has access to the private and protected members of the class. Okay, so this is a way to break the encapsulation in addition to the public members. So basically, let us say that we have a class A with some private or protected data members, and also some public data members. Okay, now now we know that we can access all the public data members from outside the class. Okay, if we write some global function, okay, if we write some global function, then it can access all the public data members of class A, but it cannot access the private and protected members. Okay, but if we use the friend keyword, then it can break this encapsulation, and that only that function can access the private and protected members of this class. Okay, so there are some cases where this is necessary to do. So that is why this mechanism has been given. Okay, and similarly there is a concept called friend class. So friend class is similar, but in instead of a function we will have another class. Okay, and we can say that B is a friend of A, so then B will be able to access the private and protected members also. Okay, so this is similar to the function case. It can break the encapsulation. Next I'll go over operator overloading. Okay, so in the previous classes we have defined a complex class, as you know. So a complex class will have a real and imaginary numbers, but what we would like to do is we would like to add or subtract or perform arithmetic operations on these complex numbers. Okay, now by default, okay, we cannot add or subtract any class. Okay, say we have this class complex. Okay, and we create two data members, complex A comma B. Okay, now by default we cannot do arithmetic operations on these custom data types. Okay, we cannot write A plus B or A into B. Okay, but if we can do this, then it will make our lives very easy. Okay, it can simplify the coding and reduce the number of lines and number of characters. Okay, So what we can do is we can define these behaviors. We can say that if I write a plus b and a and b are complex classes, then what does it mean, and how should the compiler manage that? So we can define that behavior. So how? With the help of operator overloading. So in this case, this complex class is there, and we have the two data members, and then we have a constructor. We have a constructor which takes a default values 0 and 0, and it initializes them, and there is also a destructor which does nothing. Okay, and now here we are overloading the plus operator. So look at the syntax. It returns a complex class, and the name of the function is operator plus. Usually the format is operator and then the name of the operator. I mean, the not the name, the symbol of the operator. Okay, and then we take a reference to some other complex object. Okay, so what we do is we now define the behavior of the addition operator, which is simple. We add the real and imaginary parts separately, and then we return this new complex object. Okay, now after we have done this, after we have defined this operation, somewhere else in our code, we can, it is possible for us to write this shorthand as a plus b, and it will work as intended. Okay, uh, similarly, if we had overridden the star operator, then we can also do a into b. If we had defined this function, then we writing this is also possible. Okay, now let's go on the second operator overloading. So here you will see a example of the friend classes. Okay, but ignore this for now. Okay, so what we see, this might be a bit difficult to read. So again we have the data members and the constructor, but now here what we are doing is uh, we are defining the output streaming and input streaming operators. Okay, we are overloading them. So what is the output streaming operator? uh, Output streaming operator is this two left angular brackets, and the input streaming operator is this two right angular brackets. Okay, so these are mainly used in the context of C out and C in. Okay, you have seen it like this, context of C out and C in. So now what we do is we uh, first write the data type, which is the output stream. So it is output stream, and then we write operator in two left angular brackets, and output stream again, OS, and a complex object. Okay, similarly for the input stream we write the same thing. Okay, so here we have uh, just declared that these functions exist. Okay, and the implementation of the functions we have provided over here. So the implementation, as you know, this is the output streaming one. So this is simple. We have the output stream and the complex object a, and we output a dot real plus a dot imj. Okay, we output that, and for the input streaming operator we take the input stream and the complex number, and then we feed the values to a dot re and a dot im. Okay, and now one thing is that you will see that these functions, they have been defined as friends. Okay, why? Because actually this output stream is a of a different class. Okay, now this is actually the problem. Output and input stream, they are also classes. Okay, and they have these private and protected data members. So okay, no, sorry. So output stream and input stream, they are other classes. Okay, and in this complex class you will see that these real and imaginary data members, they are private. Okay, so these data members are private. So the output stream and input stream, they cannot access a.re and a.im. Okay, they cannot access this. So hence we have to declare it as a friend function. Only then they are allowed to access it. Okay, you will see that, see that the definition is outside. Okay, the definition is outside the class scope. Okay, so outside the class scope you cannot access a.re and a.im because they are private data members. But if you write the friend keyword, you can access. Next, I'll go over namespaces. So a namespace is a declarative region that provides a scope to the identifiers inside it. So it is mainly used to organize the code into logical group and prevent name collisions that can occur when you use multiple libraries. So one main problem, like in C language, one main problem was that uh, all the functions and variables, they were in the global scope. Okay, so let us say you have 3 4 libraries. Okay, and you include all of them. There is a possibility that library, let us say you have 4 libraries ABCD. There is a possibility that library A and library C, they both use the variable x. Okay, both have a variable called int x. And now since in C everything is in the global scope, so there will be a name collision if both the libraries use the x variable. So in C you had to be careful to give unique names to the variables so that hopefully there is not a name collision. But in C++, we have a mechanism called namespace, wherein what you can do is you write the keyword namespace, and then you write some name. Okay, let us say ns, and then inside this namespace you write whatever you want. Okay, classes, functions, and variables. Okay, you can write whatever you want. Now what happens is that when you want to use any function or variable, you have to always write ns colon colon. Okay, inside this namespace, suppose you have a variable x, so you have to access it with ns colon colon x. So this is a way to separate out these functions and variables of different libraries and prevent name collisions. So in modern C++ libraries, you will see that the whole library is usually grouped into a namespace. Okay, so if your library is about, let us say, some GUI, okay, some GUI application, the whole library will be in some namespace like namespace GUI, something like that. And another example is OpenCV. So if you have seen the C++ version of the OpenCV library, then the whole library is in a namespace. I think it is OpenCV only. The whole library is in the OpenCV namespace. That way there is no name collision. Okay, so now we will go with the exercises. So this is the first exercise. Please try on your own. I will discuss after 2 minutes. ठीक है, अभी मैं पहला एक्सरसाइज दिया हुआ, मैं गूगल करता हूँ सॉल्यूशन. Yeah, yes, hello. So in this question, basically, uh, there is a class with there is a class my class with a static data member S, and which is also private. And then we have the public. In the public access specifier, we have a constructor which sets the value of S, and uh, then we also have increment and print functions. Okay, and the increment function increments S by 10, and the print function prints S. And then here we are initializing the value. Okay, we are writing int my class colon colon S equal to 10, and over and then now we look at the main code. In the main code we are creating two objects of my class, and then we are calling the increment method three times, one time on o1 and two times on o2. Okay, so obviously once, since no print method is being called, so there will be no output. Okay, but also this code will generate an error. Okay, uh, the error is that static data members can only be initialized once, and they can only be initialized globally. Okay, so you can see here. Okay, here we are initializing S, and this is fine. Okay, uh, this is fine. Okay, so this is actually the recommended way to do this, not recommended, the only way to do this basically. So we initialize the data member here, but the problem is with this constructor. You can see that this constructor has a initializer list where we are initializing S again. Okay, we are initializing S once with 5 and another time with 10. Okay, and this is not allowed. Okay, this is not allowed. So uh, we cannot have a static data member in a constructor, because a constructor initializes the values, and the static member can only be initialized globally, like this as shown. What we could have done is, we could have if we wanted to replicate the same functionality, we could have set the value of S in the definition of the constructor. So suppose I write the constructor like this, and inside the definition we can write, in the constructor body basically, we can write S equal to minus S. Okay, so this is actually different from the initializer list, because the initializer list, it initializes the variables, but here we are assigning the variable, which is different, and this will be allowed. Okay, so this will be allowed, it will have the same output, but this is allowed and this is not allowed. Okay, so now we'll move to the next question. So this is the next question, please try on your own. Okay, now I'll discuss this question. So, basically in the here we are defining a class called point with two private data members x and y. Okay, and then we have the in the public access specifier we have a constructor that sets the values of x and y with r and I. Okay, it takes two arguments r and I and it sets it. Next, here we are overloading the output streaming operator. Okay, but you will note one thing. Actually, this is quite interesting. So here we are overloading the output streaming operator, but this operator is actually a binary operator. Okay, so this output streaming operator, it takes two arguments on the left and the right side. Okay, so the way this has been written, it means that on the left and right will be 2 point classes. On both sides there will be 2 point classes. Okay, so let us say that we have 2 points, uh, we have 2 points r and s. So it will be something like r output stream s, something like this. Okay, so anyway, let's see the behavior. So it takes this point c and it prints x plus cx and y plus cy. So now what is this x and y? This is the data member of the class. Okay, so we are taking, so we are calling this output streaming operator between two objects. Okay, let us say r and s. So this x and y will come from r, and this c dot x and c dot y will come from s. Okay, so if we are, for example, writing like this, r output stream s, so this x and y, this will come from r, and c dot x and c dot y will come from s. Okay, and finally what we do is we return, we dereference this pointer and then we return it. So basically it returns a reference to the r class. Okay, uh, now, and then here we declare a friend function between output stream and point class c. So from the function signature, what we can see that this output stream operator, it operates between a output stream and a complex object such as r or s, as I've written here. So you can write output stream r or output stream s. Okay, and the output stream could be a cout object. Okay, and here we are providing the implementation of this output stream. Okay, so we have this output stream and the c class, and what we are doing is we are simply printing the values. Okay, and I think yes, here should have written the friend keyword. Okay, the friend keyword would be there. Now we come to the main class, main function. In the main function we are defining 2 points c1 and c2 with coordinates 2 comma 5 and 4 comma 6, and now we have this line. Okay, so this line, it will execute from wait a minute. So okay, one more thing. So this function that we have overloaded here, you can notice an interesting thing. That we take a output stream and a point c, and then we print the values c dot x and c dot y to the screen, but at the end we return the point. Okay, we return c. Instead of returning the output stream, we return the point c. So now we come to the main function. So what happens is that first this c out and c1, this line gets executed. Okay, so because of this line, since your c1 is 2 comma 5, it will print 2 and 5. Okay, but this function will return a point object, which is the point that we have inputted. Okay, so this will return c1. Okay, and now next we will have this output stream between c1 and c2. Okay, in this case in this case your this function will be executed, okay, because now this is the output stream between two point objects, okay. So what it will print is the vector sum of the points. So your 6 and 11 will be printed, which is the addition of these coordinates, okay. So somebody is trying to repeat it, so okay, I'll repeat this question. But basically, see, this line is there, C out output stream C1 and then output stream C2. Okay, you can split it into two parts. One is this and the second part is this. One is this, second part is this. So the for the first part, let me write here 1 and 2. So the first one gets run by this function, okay. So this one function is called for the first part, and for the second part this function is called, okay. Let me repeat this one more time. So in this question, first we have a class with two private data members x and y, and then we have a constructor, simple constructor, and then we are overloading the output streaming operator, okay. But we are giving two implementations for it, okay, one here and one here. And now what is the difference between the two? So basically your output streaming operator is a binary operator. It takes two operands a and b and then it returns something, okay. So what we can do is we can provide different implementations for different combinations of a and b, okay. For different combinations of a and b we can provide different implementations. So that is what is being done here. So first let's look at the second implementation. So in the second implementation we are giving two arguments. One is a output stream and another is a point object, okay. So this operator, it will operate between a output stream and a point object, okay. And for the first implementation you can see that it has only one argument, which is c. So what does it operate on? Okay, so it operates on the current object and some other object. So you can think that the current object is this, so it operates between this and c, which is the other object it takes. So in case of the second one, it is a output stream between a output stream and a complex object, and in the first case it is a the operator works between two point classes, okay. And you can see the behavior here. So in the implementation, uh, implementation what we are doing is we are printing x plus c dot x and y plus c dot y, okay. And for this one we have implemented it here. Here we are just printing the value, there is no summation. Now one thing you have to be careful about is what is it returning also. So let me write here 1 and 2. So 1 is returning a point. You can see it returns star this. Now this is written in a point class, so star this will return a point. Now coming to the second implementation also, you can see that it takes output stream and a point object and it returns the point object. So this one also returns a point. So both the implementations they return points. Now we come to the main function. So in the main function we have two point objects c1 and c2, okay. They are initialized with coordinates 2 comma 5 and 4 comma 6, okay. And then we have this line which is the main line of the function. So you can think that it executes in two parts. First, so it executes from left to right, okay. So first this part is executed, c out output stream c1. So what? So which of the functions will this call? This is a output stream, and uh, this is a point class. So it will call the second function. Okay, it will call the second implementation, because this takes the output stream and a point object, and it returns a point object. So it will call the second implementation. Uh, you can see the behavior. It just prints the values. So it will just simply print 2 and 5, and it will return the point. So this will return C1. Okay, now the second part of this line will be C1 output stream and then C2. Now here both the arguments left and right, uh, wait a minute. Okay, so there was a network problem. Anyway, so the okay, so and there was a network problem. Okay, let us resume. So yeah, so the first part works like this. We have the C out and the C1, and it returns C1. And for the second part, we have C1 output stream C2. Now here both the operands, they are of this point class type. So this first function will be called. Okay, this function will be called because here both the left and right operands, they're point classes, and you can see the behavior that it uh, sums up the sums up the coordinates and it prints them. So 2 comma 5 plus 4 comma 6 will be 6 comma 11, and that will be printed. So the output will be this. Okay, so moving on to the next question. So this is the next question. Okay, so this question is mainly about namespaces and the namespace resolution operator. So you can see that we have this variable var and it is declared three times. So once we have declared it globally, and once within the namespace called name. Okay, so here we have defined a namespace called name, and then within the curly braces we have defined the var variable again. And then once again within the main function we have defined var again. Okay, so now here we are printing it. Okay, so one other thing is that we have written here using namespace name. Okay, so that will use the this namespace. uh, Anyway, so in the printing line we have colon colon var, and then we have var without the colon, and then we have name colon colon var. So colon colon var means the global namespace. So this will print 0, which is the global one. And for the last one which is name colon colon var, it will print this 2. And for the middle one, here we are just printing var, so it will print var within the main function. So 0, 1 and 2. Okay, so the this is the next question. Okay, now we'll go over this question. Okay, so in this question we have defined a class called my class with two static data members x and y, and then in the public scope we have a function called print, which prints x and y. Okay, and then we have two other functions, set x and set y, which sets the value of these data members. And here we are initializing these data members uh, globally, as you can see. And this is the main function. In the main function we are declaring two objects of my class type, and we are setting uh, x and y to 4 and 5. Now one thing you must remember is that uh, since x and y, they are static members, so they are shared by all the objects of the class. So t1 and t2, they both share the same value of x and y. So if you write t1 dot x, it will be 4, and t1 dot y, that will be 5. And this is the same as t2 dot x and t2 dot y. Okay, they will give the same value. And finally we are calling my class colon colon print. Now one thing which is different here is that we are using the class name directly instead of using any object name. Like instead of saying t1 dot print, we are writing my class colon colon print. So this is a new thing. Okay, new way of writing. So obviously since we are invoking it like this without any object, so this print function, it must be static. So in this blank we have to fill static. Okay, so now moving on to the next question. Okay, so one thing here is that we have in this blank we have to uh, use namespaces. You cannot, you cannot simply write here x equal to 15. Okay, like avoid setting just this. Okay, Okay, so again, so this is a question about namespaces. So here we have a variable x, and it is defined three times. Once globally, and then once within the namespace called e, and once within the namespace called e1. Okay, so another thing is that this namespace e1 is nested within the namespace e. So if we want to access this variable inside, we'll have to use e colon colon e1 colon colon x. Okay, and here we want to print 15, which basically means that we want to access this variable inside the e1 namespace. So we'll have to fill that using, okay, so we have to fill this as the in the blank. This will ensure that it uses the value of 15 instead of the global value, which is 10. Okay, now let's proceed. Okay, so in this question, uh, we have this class called const test, and it has a private data member x with some keywords. Okay, before it. Then we have in this public scope we have a constructor which initializes x, and then we have a function called set which sets the value of x, and then we also have the print function which prints the value of x. Now one thing you will notice is that this set function, it sets the value of x, but it is also marked as a constant function. So as you know that a constant function, it cannot modify the state of the class. Okay, so this should generate an error. Okay, this should generate a compiler error, but here we want the value 10, so we'll see how we can get around it. Then in the main function we are declaring a constant object called m, and here we are setting x equal to 5, and then we are further setting m as 10, and then when we call the print function we want this value of m to be printed. Okay, so basically how do we, the question is that basically the question is how to modify a constant object. So this is the question, how to modify a const object. So the keyword here is mutable. So you have to either write mutable int or int mutable. Okay, so if you write this keyword, then it will allow you to modify x even though the object is declared as a constant object, or even if you have this const in the function. Okay, so now I'll explain that why is this keyword given and why we might want to modify a constant object. So this mutable keyword, it is for meant for those classes and objects where there are some data members which do not affect the external, you can call the external appearance of the object. So let us say that we have this class, and here we have three data members. Okay, so let us say two data members, int x and y, and both are private, and now then we create some public function, and we write get x, this returns us x, and then we write set x, this sets the value of x. Okay, but we do not write any function to modify y. Okay, okay, we have not written any function to modify y. Now if there is some other function or class or object, when it works with this first class, it can only access or change the value of x. Okay, so only x is accessible. Okay, the y data member, it can be modified internally. Okay, so y can be modified internally by the class, but the only the x variable is accessible from outside. Okay, so from outside the class, if the x variable stays constant, then the whole class appears to be constant. Okay, so in these cases, what we do is we set y as mutable. So we set y as mutable, then we can call this, we can make the whole class constant, and only if x is, in that case only if x is fixed it will work. Okay, now going to the next question. So this is the next question. डिस्कशन खत्म हो गया डिस्कशन खत्म हो गया नया डिस्कशन है कि कल क्या स्लोगन चिल्लाएंगे रुको, थोड़ा धीरे बात करो okay, so in this question we have declared this namespace called name, and inside this namespace we have a class called student with a private data member called roll number, and then we have a constructor which sets the value of roll number. Okay, so it sets uh, roll equal to x, and then it has a print method which prints the value of the roll number. And now this is the main function. In the main function we basically have to create a object of type this object of type student, and then we call the s.print method. So this question is basically about how do we access the student class which is inside the namespace name. So for that we have to use the colon operator, as you know. So okay, so this is the answer. So this will access the namespace. The student will access the student class, and s is the name of the object, and then 5 is the argument which initializes the student. Okay. Okay, so uh, there's a question when to use namespace and when to use only name of a namespace. So this namespace keyword is only used when you declare the namespace. Okay, so you can say that it is only used once. So you write namespace and name or something. Okay, and this namespace word is used only once. Later on, if you want to use anything which is inside the namespace, you just write the name of the namespace. Okay, you don't have to write the namespace keyword. Okay, so okay, so then moving to the next question. So please try this question on your own. अभी शुरांशु का प्लान है कि कल जय श्री राम। हाँ हाँ मेरा भी नहीं आएगा। हाँ क्लास है। मैं ऐसे पढ़ा रहा हूँ, सब लोग भाग छोड़ के जा रहे हैं। So, so in this question we have this point class with two private data members x and y, and there is a constructor, and then here we have overloaded the output streaming operator. We have overloaded the output streaming operator to print open bracket p dot x p dot y. So p dot x and p dot y. So one, like, notice here that what are the arguments and what is the return type. So the arguments are the output stream and a point object, and it also returns a point object. And so since the arguments are a output stream and a point object, so this will operate between a output stream such as c out and a point object such as p. Okay, so this is the context in which it will operate. Next we have the main function. In the main function we declare an object called pt with the arguments 2 comma 5, and then we call cout pt. So this we wanted to print 2 comma 5, which is we simply wanted to run this function. So for that, within the class we have to put its function signature. We have to put its function signature inside the class. So this whole thing we have to write here. But one thing is that since this is a, like, this function is of the output stream class, and it is accessing the private data members of the point class, so we have to use the friend keyword. So basically we have to write this function signature with the friend keyword. So this whole thing will come here. Moving on, so this is the next question. Okay, so in this question, we want the output to be 5 and 15. Okay, so here we have two classes, class A and class B. So in class A, we have a private and static data member called A, and then we have in the public access specifier we have a get function which returns the value of A, and then we have one line which we have to fill. And in class B, we have another data member B, which is also private, and in the public scope we have a constructor which sets B equal to Y. It sets B equal to Y, and then we have a print function which sets A is A. Okay, so you can see in A, the small a, which is the data member, it is a static data member, so we can access it without any object. So we can write A colon A to access it. So we are setting it to 10, and then we are printing here A minus B and A plus B. So it will be 10 minus B and 10 plus B basically. Now we want the output to be 5 and 15. So basically B is 5. If B is 5, then it should print 5 and 15. Okay, so now we come to the main function. So another thing is that over here we define we initialize this static data member small a as 0, and then in the main function we create the t2 object with small b as 5, and then we call t2 dot print. Now the question here is that since small a is a private data member of the capital A class, so how do we access it from class B? So for that we have to again use the friend keyword. So here what we can do is we can write here friend class B. Okay, so that way we can access A's data members from B. And now moving on, this is the next question. Oh, it is similar to the question that we did before. So this is similar to the question that we did previously. Okay, so in this case we want the output to be 5. So we want to, so the we want to access this x variable of the e namespace. So you can see that there are, the x variable has been defined 3 times, once globally and once within the namespace e and once within the namespace e1. And here we want to print 5, which means that we want to access the x variable which is in the namespace e and not the global one or the in the e1 one. So we can, like the similar to the previous question, we can write here using e colon colon x, and that will use the x which is inside the e. Otherwise it would have used the global x and it would have printed 10. Okay, so that is the solution. Okay, so that is all for today. Okay, so the class is over. Okay, so there is a question, why using here only and not namespace? Okay, so this using keyword, okay, using keyword can be used in two contexts. Either we can use using namespace and then we can write the name of a namespace, or we can write using some variable, okay, like in this format using e colon colon x. And so if we write using namespace this variable, then the that namespace will be treated like as if that namespace has been included in the global space. Okay, but if we write using then some variable name, then that specific variable will be used in that scope. Okay, so see this main function, this is inside a scope, right? This is inside this scope. So if we write using namespace and then some name here, then it will be treated as if this scope is inside the namespace which we have written. Okay, but if we write using and then some variable name, then only that variable will be included in this scope. Okay, so thank you for attending today's class.